Welcome to webinar on industry standard plastic design and overview of Siemens NX. In this webinar, I'll be giving an introduction on basics of plastic design based on industry techniques and also introduction on a well-known CAD software known as Siemens NX. So let's go through the content for today's webinar. So at first, I'll be introducing about the plastic, like what is definition of plastic and what are the classification of plastics and some of the most commonly used plastic material in industry and its applications. And then I'll be giving a brief about introduction to Siemens NX, like which industry uses this software and what are the applications of using Siemens NX. And after that, once you get a theoretical knowledge on plastics, then you need to have some kind of a tool to design. So then it will be a Siemens NX. So once you have the plastic design knowledge, it can be combined with the software, which is Siemens NX. So this will be about the introduction to plastic design using Siemens NX. And then after that, I'll give a brief overview about the technical concepts, like how the industry follow standard guidelines in designing plastics, and also what are the design life cycles in plastic. And also I will briefly about the current trends in the plastic industry. And then of course, the job opportunities in plastic industries using Siemens NX. So here I will brief you about various job titles and also about the companies who uses Siemens NX to design and develop plastic parts. So what exactly is a plastic? So it's a wide range of synthetic or semi-synthetic materials that uses a polymer or a plastic material as a main ingredient. So this plasticity makes it possible for the plastics to be molded, extruded, or pressed into a solid objects of various shapes. And during manufacture, the plastic will be in a liquid form, right? And then this liquid will be injected in the mold and in the core and cavity to get a desired shape. And plastics are classified into two types. One is thermoplastic and the other one is a thermoset. So what exactly is a thermoplastic? So to give you a idea on what exactly is a thermoplastic, I will give you a simple example by taking a wax, but it is nothing to do with the plastic, but to give you a brief idea or a concept on thermoplastic. So when you burn a wax or a candle, it will be converted into liquid, right? And then when you cool it, it becomes solid. And during its liquid state, you can make it into any shapes you want. And once you cool it, it will be solid and you get a desired shape, right? So this is a concept of thermoplastic. And some of the examples include polyethylene, polystyrene, polypropylene, ABS, and these are the well-known plastic parts used in the industries. And next we have got thermoset. So what exactly is a thermoset? It's a material which is a permanent solid state after being cured one time. So again, to give you a concept or to understand what exactly is a thermoset, let's take an example of an egg, right? You all know egg, and when you boil it, it becomes hard. And if you further keep on boiling it, then it doesn't change its shape, but it becomes harder and harder, right? So this is a kind of thermoset material, and this is not recyclable. So you cannot get that boiled egg back to the original shape or back to the shape how it was, right? And if you still keep on heating it, then it becomes more stiffer and stiffer. And some of the examples of thermosets are like epoxy, silicone, which you all well known, and then polyurethane, which is a foam material, and phenolic. So next I will brief you about thermoplastic injection. So it's an extremely popular method for manufacturing a plastic part, right? It will be in a liquid state and it will be injected in a mold to get a desired shape. And it is used in most of the industries. In some of the applications includes for packaging and also in the automotive industries, aerospace, and also in designing some of the medical equipments. I will go through some of the material properties and its applications. At first, we have got polypropylene. So it's known as PP. It's a stiff and strong material which has high gloss and it is resistance to scratch. It has high mechanical flex crack resistance. And the application includes, it is used in automobile industries, textile industries, electrical and electronic industries. To give you a specific example, in the automotive industry, it is used to design a radiator cooling fans and a tail light housing. And if I consider consumer products, it is used in development of camera parts, washing machine parts, etc. And here you see some of the pictures which are made up of polypropylene. So this is the parts from the door trim. And next we have got acrylonitrile butadiene styrene, which is known as ABS. It has high impact resistance. It is tough and has high rigidity, and it is low water absorption. It has a good electrical insulation properties. And again, its application used in automotive, heavy domestic appliances and helmet. And here you see some of the materials which are used in keyboards and the famous Lego toys and some of the components from the instrument panel. And it is also used to design helmets. Now you can assume how strong the ABS material is because it is used to make helmets to protect our head from the injuries, right? And next I will go through a polycarbonate material, which is called as PC. It has high toughness and it has temperature resistance, good insulation, and it also acts as a self-extinguisher. And here you see some of the applications, which is used in electronic industries and also developing a tail light lenses for automobile industries. And also it's transparent. And next I go through polystyrene. It possesses a high gloss, sparkle and transparency. It has low water absorption, also has a good electrical insulation. And the application here you see is a container which is used for hot and cold beverages. And also if you see some of the packages like a refrigerator component, toys, so it's all polystyrene. Then we have got polyethylene. It has low temperature flexibility, toughness, and it has corrosion resistance. It is soft, flexible, and lightweight plastic material. There are subtypes like low density polyethylene, linear low density polyethylene, and high density polyethylene. And these are the applications used. For example, if the stiffness is not required and also it is not exposed to high temperature or where we don't need structural strength. Here you see some of the examples which are transparent and bottles where we don't expose it to high temperature or we don't need a structural strength and it has a low thickness. So for such applications, this material will be used. And next we have got polyethylene terephthalate. So it's also known as PET. So whenever you observe on plastic material like bottles, there it will be written as PET. So this is used for bottles, for the foils, blisters, etc. And it has a good chemical resistance. It is high flexible and it's also colorless. And here is some of the examples, which is very well known, like bottles where we use for drinking water or to store the beverages, right? And the next we got polyamide. It has low melting point, good mechanical strength, and the subtypes include PA6 and PA66. And if you observe some physical parts, there it will be written on the B side of the physical part. And this is some of the example which is water resistant, and also it is used as it is also known as nylon material, and also used for medical use to develop transparent parts. So next I will go through thermoset materials. So as I explained previously, these are the materials which go into a permanent solid state after being cured one time, right? Like an example of egg. So it cannot be recycled, and it is used in automotive industries. For example, foam material, which is a PU foam, polyurethane. And when you burn it, so it cannot be recycled, right? So it becomes hard at first, and then if you keep on heating it, then it will be converted into a carbon. So which we cannot recycle it. And these are the materials which are not used much in the industries because of its problem with the recyclable. And here you see some of the applications like automotive headliner, which is a soft material. It's kind of a foam. And also the example here, it's shown as a seating foam. And there are some other materials like urea, epoxies, polyester, etc. Now I'll brief you about what are fillers and additives, why we use it, and what are the importance of these. Fillers are the materials which are added to the polymers, right? And it which improves the specific properties like mechanical strength or thermal resistance, and also it makes product cheaper or a mixture of both. And that's the reason fillers and additives are used in the industries with the plastic material. Like what exactly are the properties changed by using fillers and additives? You can change the color, increase flexibility, increase flame resistance, weather resistance, and processability. Now, again, if I take an example of wax, now when you heat it, it will be converted into a liquid, right? And when you add some color to it, and then after mixing and after cooling it, then the color of the wax will be changed, right? This is a kind of a fillers and additives. You can change the color of a plastic material. You can add more resistance and also for manufacturability. For example, now the material which we gone through previously will be mixed with some of the materials. Like for example, if you go through some of the plastic material or a physical part, and when you observe it on the B side, there you see a plastic material exactly written on it, like PC plus ABS or PA6 plus GF15. So it's a mixed with glass fiber 15 or glass fiber 30 to increase the stiffness or to increase its mechanical properties. And that's the reason fillers and additives come into play. And next, I will go through the overview of Siemens NX. What exactly is the Siemens NX and what are its applications? Siemens NX is a software which is flexible and powerful tool, right, in designing, and it is used in many industries, even from small scales to big scale industries. Initially, it was known as Unigraphics NX, and after takeover from Siemens NX, Siemens, it is converted into Siemens NX, but the NX remains the same. It is generally called as a next generation, Siemens next generation. So that's the reason it's called as Siemens NX. It's a high-end designing software, manufacturing, and also analysis can be performed using this software. And it was originally developed by UGS Corporation. Since since Siemens PLM owns it from 2007, it is known as Siemens, and it's a powerful, innovative, and user-friendly tool, which is used in most of the industries, right? And if I say powerful and user-friendly, just by a click of a tool, we can perform various operations. We can design a part from the scratch until the manufacturability. And There are easy tools. Just by click of a tools, you can perform all these operations. That's why this is called as a powerful and user-friendly tool. So you don't have to do some programming or nothing. So just if you have a idea how to design a part or how the part looks like, then you can use this tool in designing those parts. And that's the reason Siemens NX is used as a tool. And exactly what are the advantages of Siemens NX? Now, when you have some ideas in your mind, you need to have some tool to transform this idea into a realistic 3D modeling, right? And even if you want to explain or if you want to showcase your skills to the management or to show what is your idea, then you can use this software. Then you can convert your ideas into a realistic model. And then it will be easy to explain or see how the part looks like. And using this, it lowers the development cost and also it improves the product quality. So there you can make some iterations, do some analysis, and based on the analysis, you can change the part to increase its product quality. And also you can consider some manufacturability well in advance before the problem is detected during the manufacturability. And also some of the assembly sequencing to identify what are the complexity involved during assembly. Because often you hear from the automotive news, like there is a recall of some 100,000 vehicles because of some safety issues or some assembly issues, right? So this can be detected well in advance by checking the assembly sequencing. And also there we have got a motion simulation application where we can exactly check how the parts behave during motion and also used for packaging. And using motion simulation, we can see what are the exactly issues involved during motion, right? And then also we have got design simulation where we can do post-processor, pre-processor to optimize the part, like applying the load conditions and checking where the part is getting failed or where the stress is much on the plastic part, and then the strengthening features can be added to it, or also to reduce the weight where there is less stress or less load. There we can reduce some material for the weight optimization. So these are some of the advantages of using Siemens. And I'll just brief you about the screen interface. This is the screen how it looks like when you launch Siemens NX. And then here you see some of the applications like modeling, sheet metal, shape studio, and drafting. So these are the designing applications. And we have also got assembly workbench, or it's also called as assembly applications, where we can assemble all the created parts using modeling or shape studios or sheet metal. And then we can see what are the issues in the assemblies. And also it helps to generate bill of materials, like how many parts are included, list of parts with the materials. And as I explained before, these are the motion simulation application and design applications where we can create a kinematic and also we can do the analysis of the part using pre-processor and post-processor. And it is a complete package. Once you have all these knowledge, then you can by yourself design a part from the scratch, and also you can do the analysis by yourself and also optimize the part by yourself. And then you can work independently in the industries where you don't need much support from your superior. So that's the reason it's a powerful software. I'll brief you about which industries are using Siemens NX. It is used by aerospace and defense in creating aircraft engine, airframes, and land systems. Then also used in automotive and transportations like automotive OEMs. So OEM meaning original equipment manufacturers, like the car makers. One of the example is Daimler. They also use Siemens NX in designing, and also suppliers like tier one suppliers, where they create a part and then they supply those parts to the automotive OEMs. So these are called tier one suppliers. And also it is used by commercial vehicles like trucks and buses. It's also used by consumer products and retailing like home appliances, washing machine parts, dishwasher, where you see everything, most of the parts are plastics, right? Also used in electronics and semiconductors, industrial machines and heavy equipment. Like with the motion simulation, it's easy to do the packaging with the excavator mechanism, what is the angle of the moment, how much it has to rotate, etc. So this can be done in motion simulation and also used in marine, like commercial shipbuilding and also in building a naval ship, both for commercial and marine. And it's also used in medical devices and pharmas, like designing medical equipments, medical instruments, etc. And some small and medium industries such as tooling and fixture design. So using Siemens, there are a lot of opportunities in all the fields. You just name a part and all these industries uses Siemens NX as their designing software. And in all these industries, at least 20 to 30% of plastic parts are involved, right? So if you see a vehicle inside and whatever the parts you see as an aesthetic look are all plastics. Okay, now let's brief you about the plastic design life cycle, how the industries follow uh, design life cycle in designing a part from scratch until the production or a serial production. At first, it begins with a design studio, which is a hand sketching, creating a clay model with like 1:1 scale, and then it will be converted to a class A surfacing, and which will then be given to a technical team to check its feasibility. Because whatever surface developed from a design studio sometimes will not be flexible, or it's not like manufacturing feasibility, right? That's why it is given to the technical team. They will check its feasibility, and then also there will be a part split, because once you get a design studio, it will be a complete surface without the part split. And then we as engineers should define those part split and then create a bill of material or generate a bill of materials, and then how the part split has to be done and how is the attachment concept, and everything will be done using benchmarking. Now, what exactly is a benchmarking? It involves a structured comparison between similar products. Now, for example, when you are designing a plastic part, those parts are already existing, or a similar concept is already existing with a different car manufacturer or from the different industry, right? And then you take those parts and compare it, and then you can define what changes to be done, and this makes it easier to improve the quality of the product. And that's why benchmarking is very important in the industries. Like there's a saying, right? When you start a part from the scratch, it's like reinventing a wheel. So if you already know the concept of wheel, then why to reinvent it, right? And there's also a saying like, don't set a benchmark, do the benchmark. Setting a benchmark is different and doing the benchmarking is different, right? Because setting a benchmark involves a lot of time, a lot of money, and then it takes too much of time in developing the part. If you are doing from the scratch and if you're not considering the benchmark. So if you have a benchmark, then it's easy to define the parts. Like it allows like significant difference to the product effectiveness, and also it increases the efficiency of that particular product, and also creates a lot of opportunity in innovations. If we have compare through 2 or 3 parts from the previous program or the existing parts, then you can uh, check how the part should be improved and where the innovation comes into a play, right? And after benchmarking, there will be a concept generation. For example, if you are working in an industry and if you want to generate a concept or develop a concept, then at least 3 to 4 concept has to be developed, and then showing the advantages and disadvantages of those concepts. And then there will be a brainstorming session. Like as a designer, if you are developing a concept, then you will be inviting your team for the brainstorming session where you will be explaining why you created those 3 to 4 concepts, what are the advantages of it, and what are the disadvantages, like what are the cost involved, how is the assembly process, and what is the complexity in the manufacturability. And then you'll be giving a rating. And as a team from the brainstorming, one of the concept will be selected, right? And then that particular design will be freezed. And after freezing, and this particular concept will be developed. Like development involves like attachment features, assembly process, master sectioning, and then defining the thickness, where the parting line should be, and how the assembly should be done, and what are the concepts involved in attachment, right? After that, there will be a manufacturable feasibility, like defining the tooling direction for the core and cavity. And then there will be a layout check, like where you put all your parts in the 2D drawing, defining sections, attachment sections, how the part is connected to the structure or with the interfacing parts. And then after that, there will be a release for prototype. So the part will be developed as a prototype, and then the testing will be done, physical testing. And then based on the testing, again, there will be some modifications. Like if the part is getting failed, and then there will be a analysis like the VE activities, vehicle engineering, where a team or as you are as a designer, you will be investigating what went wrong and how to fix the problem. If the part is getting failed, then you analyze it where it is getting failed and how to strengthen it. And there will be a part change or there will be some modification. And after that, the again process continues. Again, there will be a feasibility check. Then you put it in a layout drawing. Then again, you release it for prototype, do the testing again. And once everything is okay in the results, and then it will be released for production, right? So this is the general process where you create a part from scratch till the production or the serial production release. I will go through some of the plastic design guidelines and why we consider these guidelines in designing plastic part. At first, we check the wall thickness. Now, the part wall thickness has to be adequate and it should be consistent. And the thickness varies from 1.5 to 3.5 millimeters, depending upon the application or the requirement. Now, wall thickness strongly influences many key characters like mechanical performance, feel, or the appearance, and also moldability, right? The optimum thickness is often a balance between opposing tendencies like strength, weight, durability, and cost. And when you define a wall thickness, you should have a careful consideration in the design stages to avoid expensive mold modifications and also mold problems in the production. After the wall thickness, then the next important aspect will be the rib to the wall ratio. Now, whenever you see some of the ribs on the B side surfaces of the plastic part, the rib thickness at the base will be 40 to 45% of the wall thickness.